Okay, so today we are starting lesson 6 in chapter 5. So we are in 5-6, and today we are talking about law of sines. So we are done with the right triangle trig. You need to know it. You need to know how to do it. You need to know how to find angles and sides. That's just an expectation now. Okay? We are now going to be trying to figure out and using law of sines and law of cosines to find non-right triangle triangles. So the nice thing is it's not only right triangle trig, you can also find non-right triangle trig using law of sines as well as law of cosines. So first thing I need to do is I need to give you, well, what is law of law of sines? So law of sines. So given a triangle ABC, okay, that is non-right, okay, which means there is no right angle, okay. Then the following is true. A over sine of A equals B over sine of B equals C over sine of C. That is law of sines. Where, again, little a, little b, and little c, are those sides or angles? Sides. Capital A, capital B, capital C are angles. Okay? Now, I'll give you a second try. So that is the law of sines. Emphasis on the fact that it is a non-right triangle. Okay? Now, as you see there is 3 ratios that are equivalent. A over sine of A, B over sine of B, C over sine of C. You can't solve 3 equivalent things at once. So what you have to do is you have to pick 2 and use those 2 to solve for a missing side or a missing angle. So for instance, if I want to solve for B and I know A and sine of A, well then I can solve for B by just doing A and B. Okay? Or I could do A and C. Or you can do B and C. But you cannot do all 3 of them at the same time. You have to have 3 pieces and find the missing 4th. Yes. So you have to have 3 pieces of info and find the missing 4th. Yep. You can then use that to find everything else. The unfortunate thing is for sides, if it's a right triangle, what do we use to find a missing side? Pythagorean theorem, right? A squared plus B squared equals C squared. That doesn't work with non-right triangles. So if you're missing a side, you have to do law of sines again to find that other side. There is no shortcut with Pythagorean theorem here. Now, with angles, there's also no right angle. So finding one does not tell you the measure of the other. If you only have one angle, you have to find the other 2 by doing law of sines. And then what do you know a triangle has to still add up to? 180. So once I know 2 angles, I can find the third by adding them up and subtracting from 180. Okay? And we're going to do some examples of this, so it's not just going to be, okay, figure it out from that. Okay? So here's the example we're going to look at. We're going to solve triangle ABC if angle A is 33 degrees, angle B is 105, and side B is 37.9. We're finding side A, side C, and angle C.
Is it 10.5 or 105?
105.
Oh, because we can find side C because we got the other 2 degrees. Right. We got the third one too.
So, when we're looking at this, thing I always look for is, okay, I have to have either 2 sides or 2 angles. What do I have 2 of in this case? Angles. So if I have 2 angles, I can find the third angle, correct? I just add these 2 up, and what'd you say it was? 42? Okay. How did I get that? 105 plus 33 is 138. 180 minus 138 is 42 degrees. Good? Make sense? Okay. So we've got that. We now know all 3 angles. Okay? So now I just need to find the other 2 sides. So, again, to do law of sines, I have to have 3 pieces of info. Either 2 angles in one side or 2 sides in one angle. So if I look here, what is the one side that I know? B, right? Do I know angle B? Yes. So I know when I'm finding A and C, I have to use B, because that's the one that I know a side and angle pair. You're going to hear me say that a lot. What's the side angle pair that I have? So what's the given piece of information that I know both side and angle? Okay, so I'm going to use B. Now it's just a question of, we want to solve for A or C first. And it doesn't really matter.
C.
C. Okay. So we want to solve for C. So if I'm going to do this, B is the given that I know I need to use. And C is the one that we have chosen to solve for. So that is the part of this that I'm going to solve for first. And now, once I plug in the information, how do you solve equivalent fractions or proportions? How do you solve these? Cross multiply and divide, right? Same concept here. So, little b, 37.9 equals little c, don't know it, over sine of b, well, b is 105, over sine of 42. Does everyone see how I got those numbers? B with B, C with C. Okay? Now, as we said, we cross multiply. So I get C times sine 105 equals 37.9 times sine 42. Again, what am I trying to solve for here? So what do I need to get moved to the other side? Sine of 105. So I'm going to divide both sides by sine of 105. So C equals, I do that, again, making sure my calculator's in degrees. I get that C is 26.3.
That's only
0.25. Okay, now I do not hit equals here. I push 37.9 times sine of 42 divided by 105. There is no equal sign until the very end. You have to make sure you close a parentheses here and close it on the bottom. Okay, you have to close the parentheses of your sign. Did you get the same answer? That's fine. So I did 37.9 times sine of 42. Close the parenthesis on sine. Then divided by sine of 105. You have to make sure your calculator's in degrees. If it's in radians, it's not going to work. All right. Questions on side C? How do I find side A? Side A now. I do the same thing, right? Use A. Now, could you use C? Yes. But again, if your answer is wrong for side C, and you use that to find side A, then your answer for side A is also going to be wrong. So again, always use the side angle pair that you have, which is B. So I'm going to do A over sine A equals B over sine B. And again, does order really matter there? A or B first? No. I just always go alphabetical. So, little a over sine of big A is 33, equals B, 37.9 over sine of 105. Questions on how I set up that ratio? How do I solve this ratio? Cross multiply again. A times sine 105 equals 37.9 sine of 33. Yes. Again, want to get A by itself. So I divide by sine of 105. I do that. A is 21.4. Now, good way to check yourself is look at your angles. What's the biggest angle in that triangle? A, B, or C? B. So what side should be the biggest? B. The side opposite that angle. What's the smallest angle in your triangle? A. So what should be the smallest side? A. Do our answers correspond to that? 21, 26, and 37, okay? Does that concept make sense? The smaller the side, the smaller its opposite angle. The bigger the side, the bigger its opposite angle. Okay? Questions on that?
No, that was probably one of the things that I actually.
All right. We're going to do one more like that. You're going to do this one by yourself, yes. Okay? Solve triangle ABC if angle A is 40, angle B is 59 degrees, and C is 14. That's little c. So side C is 14. That's little c, yep. Yep. So angle, side. Draw your triangle, find the missing sides and angles. Give you a few minutes to work through that. Your triangle does not have to be drawn to scale, so don't worry about trying to draw it to scale of your angle.
Calculator. There you go.
You don't need anything to do that.
You wouldn't have to. I think it was solid. You don't want to draw a triangle, you don't have to. A over side, whatever it was. No. So it's all a matter of what you're trying to find. You want to find A or B. Yes. You always use the same side number of pairs. So if you're finding A, use angle A. If you're finding B, A, C. What's up? Okay. Give me 1 second.
I'm an error, so I must be typing it wrong. I think I typed it wrong.
Are these numbers going to be accurate? Because B is smaller than C.
But these ones are all the time. B is smaller than C.
Yeah. So that's all one.
Now C is the biggest angle, so you're okay.
Yeah, that is fine.
I'm sure you can start getting
I was like,
Ooh. You just have to
Perfect. Yeah.
okay, I'm just looking at it. So like
You know why?
May I borrow your calculator? Ainsley, you don't have calculator.
Time is 7:59 divided by 1.
All right, looks like most of us are. Give you 30 more seconds.
2 more minutes. But I'll be done.
I got 81 over.
So we got 14 times.
Okay.
59.
B over 13.
Is it decimals?
Yep.
Wait, can I just do the
All right, here we go. Gonna go over this. So,
I don't know how.
That's why.
okay, so 50, 40, and 59 added up is 99 degrees. We know a triangle has to add up to 180. So that tells me angle C is 81. And again, looking at my angles, which one's the biggest? C. So that tells me my sides I get for A and B better be shorter than 14. If I don't, that tells me I did something wrong. Now, we've got to find the other two sides. So I'm going to have to do law of sines twice, because again, Pythagorean theorem doesn't work. What is the side angle pair I'm guaranteed here? C. So I'm going to use C. I'm going to find A first. So I'm going to do A over sine A equals C over sine C. So little a, I don't know that. Big A, I do know. Sine of 40. C is 14 over sine of 81. Okay? So, if I work this out, I get A times sine of 81 is 14 sine of 40. Divide by sine of 81. A is 9.1. Okay? B. I'm still going to use C again because that's what I'm guaranteed. Okay? I've got B over sine of 59 equals C over sine of 81. So B times sine of 81 is 14 sine 59. Divide by sine 81. So what's B?
12.1.
And if you look, A and B better be smaller than C. It is. You're in good shape. Okay. Questions on law of sines? Okay. One other concept in this section. We can also use law of sines to find area of a triangle. Okay, so if I have a non-right triangle, I can find the formula or find the area of that triangle by taking 1/2 times AB sine of C. Now, what I want to be very clear on here is this does not always have to be AB sine of C. This could also be 1/2 AC sine of B, or 1/2 BC sine of A. Basically what it is it's two opposite or corresponding sides with the angle in between. So it has to be a side angle side setup. You have to have a side, the angle in between it, and then the other side. So just to give you a visual representation of that, I've got A, B, C. That means this is little a, little b, little c. So 1/2 AB sine of C. Side, side, angle in between. I can find area of that triangle if I have that set up. Again, you can use any of these three formulas. It all depends on what sides or angles you're given in the problem. You will only use one of these formulas now, though not more than one. We understand that? Okay. This makes a little more example, or it makes a little more sense if I give you an example. And this will be all we do for today. I'll give you this example and give you some practice. Okay? Everybody else need more time? I see a couple people writing yet. Just drawing triangles.
Yeah.
Alright. Here's our example. Find the area of triangle A, B, C given A equals 4.7, C equals 12.4, and angle B is 47 degrees, 20 minutes. Okay, like I said, this concept of degrees, minutes, seconds is going to come back over and over and over again in this chapter. So, do I have a side angle side pair? Do I have two different sides with an angle? Yes. So, then, which version of the formula am I going to use? What are my two sides? AC times sine of B. But what's the problem right now?
Sorry, I didn't quite.
What's the problem right now? It's in degrees, minutes, and seconds, right? I need it to be in just degrees. So how do I convert this? Divide by 60. So if I take this, I've got 47 plus 20 minutes over 60 minutes. What's 20 divided by 60? A third, right? So that's 0.3 repeating, right? 47.333. So we'll just say 47.3 degrees. Just round to the nearest 10. Everybody good with that? How we did that? So now that I have side, side, and angle, I just plug in chug. A, 4.7. C, 12.4. Sine of 47.3. What is it? 24.4.
21.
41.4. And now, this is area. What should area always have? And it's always, area is always square units. So when you give me an answer for area of a triangle, I will usually give you a unit, whether it's meters or centimeters or feet or inches. But if I don't, you need to write units squared. All right. Are we good on that? Law of sines, not terrible. Plug into the formula and go, right? Okay. Here's the practice I want you to do. Listen.
You need to go again. Just have flashbacks.
We should cover this though. Just kidding, it's on Mr. Cal's back.
There's just that one big slime.
That one big slider. What do you think? Let us come rub his back like, oh, we got it off.